Kids. So today's video is about the arrangement of resistances in series when they are connected in series. So what do you mean by series? So series is when all the three resistances are connected end to end. So what do you mean by series? So they are connected end to end, one after the other. Okay, so in this case, let resistance R1, R2, R3 be the resistances connected in series. Okay, there's an ammeter here to measure the current in the circuit. There's a voltmeter to measure the potential difference between the endpoints, extreme endpoints. Okay, let those endpoints be x and y here. Okay, so this is the potential difference between R1, R2 and R3. Okay, so the entire total potential difference of the arrangement. Let V1 be the potential difference across R1, V2 be the potential difference across R2 and V3 be the potential difference across R3. Let I be the total current in the circuit, and because they are connected one after the other, the same current flows through R1, R2 and R3. So what is the current flowing through R1? It's I. What is the current flowing through R2? It's I. And what is the current flowing through R3? It's I. Okay, so I is common for R1, R2 and R3. Okay, so what is the potential difference? Total potential difference. Okay, let that potential difference be V, and the total potential difference is the sum of individual potential differences across R1, R2 and R3. So V equals to V1 plus V2 plus V3, and by Ohm's law, according to Ohm's law, V equals to IR, potential difference equals to current into resistance. Okay, so in place of this V we can write IR. Let RS be the effective resistance for this arrangement. Okay, for V1 it will be IR1, for V2 it will be IR2, for V3 it will be IR3. Okay, so why haven't we put I1, I2, I3 here? Okay, because as we said, current is same throughout, right? Okay, same current flows throughout. Okay, now this IRS equals to, let us take I common, so R1 plus R2 plus R3. Okay, this goes off. So RS equals to sum of the individual resistances connected. Here we have connected only 3 resistances, so it is R3. Okay, if n number of resistance are connected, okay, what if n number of resistances are connected? Number of resistance are connected, what we would get is Rs equals to R1 plus R2 plus R3 till Rn. So this is the derivation for resistances connected in series, right? Okay, so remember this. What are the characteristics? What are the characteristics of the resistances connected in series? Number 1, that the effective resistance is the sum of individual resistances, right? Okay, effective resistance is the sum of individual resistances. 2, that the same current I flows through all the resistances. 3, that the potential difference between the extremes of the resistances is sum of the potential differences across each resistance. right? Okay, and fourth, that the effective resistance is always greater than any of the individual resistance. Okay, and this system is used to increase the total resistance in the circuit. Okay, so we'll see resistance connected in parallel in our next video. Okay, till then, revise properly, do your best. Bye.